So you're good to go, right? So let's see how far we go today, and we'll continue tomorrow. And you got to make a killer study sheet over the weekend. Okay? You kind of want to say like, this is going to be amazing. I have pink sheets there. You can grab your own piece of loose leaf. I don't really care. You can do anything as long as it's letter size. You can fill it up completely, both sides. Okay? Is the breakdown of the units. Watch this. Relations and functions. 16 marks. What's relations and functions? All functions we've studied. Every single one. Polynomials, exponential, logarithmic, sinusoidals. They're all bagged into just one big chunk. And you can guarantee every section will have a heading. So you're not guessing what unit am I in. You know which unit you're in. They do bleed a little bit. So I've seen them sometimes combine like a finance question with exponential functions, which you should be like, yeah, compound interest is exponential, right? So they've done a little bit of that, but not too much. How much time do you have? 3 hours plus half an hour. So if you want to stay another half hour, you're not already like dying, right? And you get to stay another half hour. There's nothing wrong with you staying longer than 3 hours, but I would say if you're here only 1 hour, I will convince you or try to convince you to not hand it in just yet. Like, look it over, okay? Please know that if it's blank, you've got 0 chances. If you write something down, we can always fish for marks. So don't leave anything blank, okay? There's this formula sheet here, which you will be getting. So let's say you missed something on your study sheet, you can rip this one out. Be careful though, because you can actually destroy your booklet if you're too. So you kind of just want to make sure you press tight, and sometimes it's perforated, sometimes it's not. I don't know why, but you just got to be careful. So you've got your four main areas that you want to check for. Keep going. I think I'm going to skip the directions this time. I want to talk about it next week. I'd rather do a little bit more math today. So let's keep going. First question. So it seems overwhelming, the booklet, but remember, 1 question per page. So a multiple choice to start off with. Relations and functions, that's the heading. Question number 1, 1 mark. Let that guide you as to how much work you will need to do. 1 mark is usually not a whole lot of work. Circle the graph which best represents a cubic. Best. Which one would you say? D, right? I hope so. Yes. Now I'm going off on a tangent. What would this be? What do you think? Exponential? I hope. Right? So that's where I go off on a tangent, because they could have asked, hey, which one is exponential? What's this one? Logarithmic. This one? Quadratic. Okay. Yeah. Where's the asymptote for this guy? It's right along here, correct? It will never. You shall not pass. I used to have a poster. Gandalf going there. And this is also for a log, it never crosses the y-axis. So if it has a y-intercept, it can definitely not be a log, right? So having a knowledge of the functions will help you greatly, okay? Let's keep going. 2 marks for this page, right? So it's 2 marks at the top for the whole page, or for that question, I should say, because sometimes it bleeds into the next page. But this question number 2, is worth 2 marks. Given the following, represents a change in the town's population with respect to time. Referring to the town, explain the meaning of 1,000. What would this mean? The initial population of the town. Be specific. Don't just be like, when you talk to someone, you don't go into much detail, because they kind of, what you're talking about, you're in the conversation, and if the person wants to know more, they ask. Pretend like that person has no idea what you're talking about. Okay, so the initial population of the town is 1,000 people. Okay, so now you've been very specific, you've added units, all of that jazz. Okay, 1 mark right there. I don't think that's too bad. So you will have 80% of the question will be fairly doable, and then you've got your 20% where you're going to be like, what is this? What are they doing here, right? So of those 20% that are head scratchers, they're usually 3 or 4 markers. So you can still score 2 fairly easily. It's the last 2 marks that you're going to struggle with maybe, but don't leave them blank. Whatever you do, don't leave them blank, okay? What does this represent? Well, maybe you look at your study sheet and you're like, well, that is B. So, but don't tell me that. Don't say on the exam, this is B. You got to be very specific to the context. B is greater than 1, correct? Indicating that the population is what? Increasing or decreasing? Yeah, population is increasing. Okay, that's what you know for sure. It is increasing. It is increasing by so and so much per year. How much is it going up by per year? Because the time is in years. If time had been in seconds, I would go seconds, right? Oh, with respect to time. So we actually don't know for sure. So I'm going to just get rid of this. Per time unit. Sorry. I know I got carried away there. How much is this going up by every year? Every time frame? 0.05, right? So we always go 1.05. We take away 1.05. That is the equivalent of 5%. So it's going up by 5% every time frame, whatever that time is. Time could be in seconds. It could be in minutes, days, you name it. All right, that's it. I think not too bad. They could have asked you to graph it. We got it. Can I go off on a tangent? What would the graph look like real quick? This would be time. This would be population. This would start somewhere at 1,000, wouldn't it? And it's increasing, so it's going like that. Right? This is just a sketch. This is not a pretty graph, but always remember, we know a lot just by looking at the equation. This is basically what they're after here, because of course you can plug this in, but if you that's not enough right now. Okay, question number 3. We're still in functions. A football player wants to kick the ball, so we'll go over the crossbar that is 35 yards away, and it's 3.33 yards high. Diagram is not to scale, so that jives, right? The description jives with the diagram, all right? The horizontal distance d in yards and the height h in yards that the football travels represented by the following equation. What does this look like? It's a quadratic, correct? I know that because of the d squared. And I know more than that. I know that the leading coefficient is negative. Therefore, I do expect my parabola to do this. And obviously, because the ball is flying this way, so that's not surprising. And my y-intercept is what? It's whatever follows whatever constant is back here. It is 0, right? So it starts at 0, 0. So a lot of information just by looking at it. Let's enter it into our calculator. You should do that too, because the window is always the kicker here. Kicker. It's being kicked. Anyways, oh, I noticed when I marked some of your quizzes or tests that some of you forgot to change your settings to radians. So let's all make sure mode You want to make sure you're in radians for sure for the whole exam radians. Okay, it stays there. Especially if you borrow one of mine, let's say that happens, you want to make sure that you're set to radians. Anyways, let's keep going. How far above or below the crossbar will the football travel? Show your work. Hold on, we'll enter it first. Negative 0.04 x squared plus 1.51. That's right. I want to see and hear clicking. So let's hit graph. My window is terrible, but you have lots of, yeah, right. So radiance only affects you when you do sine wave, which which we want. But other than that, you're not radiance. It doesn't affect all the other functions. It doesn't affect it at all. But let's just leave it in radiance because that's the only setting for sinusoidal that we want. Okay, so just leave it to radians. Do not put it back. I'll tell if I have grade 11 applied next year, I'll tell them to change it back to degrees. You keep it in radians. Yeah. All right, I'm going to change my window. I'm going to take some hints here. X, right? I'm going to 35 for sure. I'm going to go 50 for X max. Y max, I actually have no idea. I'm just going to leave it like that for now. It's a decent graph. I think we can live with it. So I'll just leave it. So now that you see it, Zoom Fit is there to help you. Another issue that you might encounter, you're listening, right? I'm looking at issues that you might encounter. When you're typing it in manually, you're given the equation. Make sure these plots are off because there's a conflict and they'll give you some kind of weird error. Check for that if you do get an error. That's usually the reason why that's happening. And Zoom Standard saves you sometimes. Just reset your window and then try it again. Okay? So what are we going to do here? There's actually two ways of figuring this out. It says how far above or below will it actually get to? Anybody willing to? I'm going to focus on the 3.33. So I'm going to let y2 equal to 3.33 because that's like the crossbar here. And then second, trace intersection. So notice that oftentimes you're going to have your own way of solving. That's fine. So I'm going to hit graph, and there it is. So I will check. So it hits it on its way up, obviously, but we're interested in here. I'm going to just go ahead and find that intersection. And I get 35.339, right? So that's 398, so that'd be 43.33. Oh, this doesn't help me really. It's just showing me that it's past 35 yards that it gets back to it, right? What should I have done instead? I'm going to check on this one. I'm going to go second, trace 1, x is equal to 35. I'm going to see like if x is 35 because it starts at 0 here. If it's 35, how high will I be at that point? Okay, so I'm going to go 35. I'm at 3.85 there. That would probably give you 1 mark right there. You doing this part right here, that's 1 mark. And we know that this height is greater than 3.33, so we will go 3.85 minus 3.33, and we just calculate that. That will be 0.52 yards. So the ball will be 0.52 yards above the crossbar. That's your final answer. If you make a statement, you don't need to circle anything because you're saying, hey, this is my answer. So what's up with this? Will you lose marks for doing that? No, because that's still accurate. Yeah, go ahead. So this is another mark for actually figuring out how much above or below you will be. Okay, so 2 marks for that page. Let's keep going. Three marks for this page, folks. For this question, I should say. A mass of a steel ball varies with respect to its diameter. You've got diameter here, you've got mass here. Okay, what does it say here? Determine the cubic equation. They give it away. That best represents this data. Sketch a clearly labeled graph of this equation. So guess what? I told you this already. I hope you remembered that the top is always L1. This is L2. You never have to guess in this case. So we're going to figure out our equation. We're going to go stat, calc, cubic, reg. That's all I need you to put there. And let's go ahead and find that equation. I hope you remember the buttons that you have to press. There we go. So 0, 5, 10, 15, 20. 0, 2, 10, 32, 80. Okay. Stat, calc, cubic regression, second 1, comma, second 2, comma. You go alpha, trace, select Y1, and there it is. 2 decimals minimum, unless they tell you otherwise. They have said round to 3 decimals before, especially if the leading coefficient ends up being 0 if you round to 2 decimals. So don't have, if it's a cubic, A cannot be 0, okay? So common mistake, it's not a big mistake, is forgetting your Y equals. So please don't lose marks for that. So I'm going to give 3 decimals just because I feel like it. Plus 0.6, that's actually 10 like this, x, minus 0.057. There we go. That would be a full mark for that. If you round to 2 decimals, there's nothing wrong with it. Now, the graph. What's the first thing you should do? Label, please. So you go diameter and go millimeters. They want a name for it and units. Then you go mass, grams. If you can avoid losing these half markers, right, it will be huge. And now you need an appropriate scale. Okay. You could use these points. There's nothing wrong with that. Maybe I will just do that. Okay. So I go from 0 to 20 along the x-axis. So I'm going to go 5, 10, 15, 20. That's it. And then you go along the y-axis, you go all the way to 80. So there you have to be careful. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, all the way to the top there. You should be experts when it comes to graphs, okay? You can verify using your calculator, do whatever you need to do. So 0, 0 is one of the points. Straight from the chart right here, 0, 0. And then it's 5, 2. So 5, 2 is somewhere here. Then it's 10, 10. 10, 10 gets me to here, according to my scale. Then it's 15, 32. That's 20, 80. So 20 this way, 80 up here, right there. So you start here. Make sure you don't go outside of this grid. And then you just, it should look like this. And you might think, wait a minute, this doesn't look like a cubic, Mr. Dirksen. It kind of looks like an exponential, doesn't it? But you don't know the behavior in the negatives, right? It could do that little bend out here. Just go with the points they gave you. Right? Yeah, go ahead. All right. Because it's this, I consider this all one question. I would say it's good enough. But if it had been like an A, do the equation, B, do the graph, I would add it. And if in doubt, just add it. Keep going. Your favorite, your absolute favorite, question 5. Let's see. Can I pause here because this should be somewhat fresh. I'm gonna pause here and see. I'm always thinking, especially when I mark your stuff. Okay, figure out your y values first. Is there a way to figure out my y values? Are they consistent? So I'm gonna actually get you started. Is there a way to figure out these three? And is there the same distance between? Can you verify that it jives with the question? Then you're going to figure out some sort of period, your X scale, like how much, where do I start? All of that you're going to figure out based on the question. So give this a try. I want you to give this a try. We can do the actual equation together, but I want to, I hope you had enough time to at least get you started. Resting position, what would that tell you? This is the mid. Resting position is your mid right there. And then it says it's pulled down 0.4 meters. So it's basically saying, hey, I'm going to pull it down 0.4, which makes this line what? You go minus, right? 0.1 of a meter. Then released. And so the implication is that it, right, guys, if this is sinusoidal, if it's 0.4 here, it will be 0.4 up here. You can be guaranteed. Right, so you add, you subtract. So this would be 0.9 meters. So those are your three y values it jumps between. And there's things to verify it. If you keep reading, right, you see the 0.5 here, that's resting position. Okay, that jives. The mass reaches a maximum height of 0.9 meters. That also jives, right? Like, so you can corroborate what you're doing is actually correct. And next, it takes 1.2 seconds for the mass to return to its lowest position. So that's your period. Your period is 1.2. And therefore, my x scale will be 1.2 divided by 4, which is 0.3 seconds. So from it jumping every time, it's going to be 0.3 of a second that goes by. All right, so it says we're starting, it gets pulled down. So you start here. Maybe I'll just keep this thing going. You start here. Then you go mid, up, and then back down. What time do we start, do you think? Time 0. Because it doesn't give us any other indication that it's otherwise. So this is 0.1. Guess what? It's going to take 1.2 seconds for it to come back here. So maybe it's a good idea to just state that right away. You see that the period is 1.2. So this would be 0.3, 0.6, 0.9, 1.2. Right? So you've got your x values there and your y values that go with them as well. So those are the 5 points you want. I'm told that it doesn't matter where you do the work on that page, you get the marks for it. Okay, so you just have to be very specific. I would try to stick here with this. So x, y. This would be time and height as well. And then just write down 0.1, 0.3.9, 0.6. Sorry, I made a mistake. 0.6, sorry. 0.3. No. Come on, get your act together here. 0.3 is 0.5. My bad. 0.6, you're at 0.9. And then 0.9, you're back to 0.5. And 1.2, you are back to that. So that's what your regression will be. So sin reg, that's good enough. Y is equal to. Do I need to do the regression? I think I will. I'm skipping them. So yeah. Oh, there's a logarithmic next. That's always. It's our time. Oof, time is flying. Always. 0, 0.3, 0.6, 0.9, 1.2, 0.1, 0.5, 0.9, 0.5, 0.1. Stat, cal, sin reg. There you go. It's 0. Did I miss one? Are you getting that? I get 0.4. Double check. Oh, I missed the 1.2. Which brings me to the topic of make sure that you enter the points right. So let's run this again. Do you know why I stopped, right? My amplitude was not 0.4. It should have been perfectly 0.4 because we know that our amplitude is 0.4. So there are a lot of ways to check whether or not you're doing this right. 5.2360 basically minus 1.57 plus 0.5. Okay, guys. This is my mid. This is the amplitude. If you go 2 pi divided by this, okay, I just thought of it the other day. If you go 2 pi divided by 5.236 and you don't get the 1.2 period, you made a mistake, right? You got to go back. So that's one way of checking. When will the mass be 0.75 meters above the table for the first time? So here you have to graph it. I would go to window right away. I know that my min is, I'm going to go to like negative 0.1, just go below, to the left of. My x max is 1.2 or so. I'm just going to go, I guess, 3 times 1.2. I told you to go 3 times the period. And then for y min, I'm going to go negative 0.1 as well, just under. And y max, the max is 0.9. So I'm going to go all the way to 1 for y max. And there's my sinusoidal graph. I need to go second trace 1. X is, no, that's not right. I'm supposed to go y is equal to 0.75 because the y axis is my height. So it happens here at the first, like at the very beginning. Okay, so second trace 5. I'm going to travel there. Enter, enter, enter. So y2 is equal to 0.75. Second trace 5, and that would be 0.43, 0.75. But please don't leave it at that because that wouldn't be good enough. It takes 0.43 seconds. That's it. That's your answer right there. 1 mark for that. And it could have asked, hey, after 0.95 seconds, how high off the ground would you be? So keep that in mind. Type this into your time as type. I'm going to stop here because this is 5 marks. Just make sure, if you're not here tomorrow, just make sure, I know it's hard. I know it's hard to say no to fun right now. But you want to work through this thing. Okay, so my goal is that by the end of tomorrow, we're done this. And then the June 2019, the white copy, I want you to do that over the weekend. Okay? And so next week, I will focus a little bit more on probability because I feel like that's the one where, let's face it, that's going to be a bit of an issue here and there. But let me tell you this, the more questions you see, the better prepared you will be. I'll say it one more time, right? The more questions you see and read and actually have to go through, the better prepared you will be, okay? So if you still want to work through this one by tomorrow, especially this log one, logarithmics are hard to graph for whatever reason. Students have a bit of a hard time with that one. Give it a go. The key is posted. Come back and let's continue to work through this, okay? Have a good one.